Okay, number 42, integral dx over x times 1 minus x quantity squared. So how do we approach this one? Can we just make a substitution? Looks like it might be doable. So what if we let u be 1 over 1 minus x? Okay, then what's du? Du would be 1 over 1 minus x squared. So if you did the chain rule carefully, so let me explain it real quick for those that don't like to jump steps. This u is 1 minus x to the negative 1 power. So if we do the chain rule, it'll be first the power rule, so minus 1 times 1 minus x to the minus 2 power. And then we need the chain rule, so the derivative of 1 minus x is minus 1. So the two minus signs would cancel, and you're left with this over here, okay? So this is possibly a good sign because my du is right there, right? Dx over 1 minus x squared. So we just need to represent 1 over x in terms of u. Is that doable? Well, if I invert both sides of this, or flip both sides, then 1 over u is 1 minus x, and we can solve for x. X is just 1 minus 1 over u, which is u minus 1 over u. You write it like that as well. You combine the two, okay? So now we substitute. So as I was saying, this whole guy, dx over minus x squared, is just my du, okay? So that's just du, and then the 1 over x, or we found what x is. X is u minus 1 over u, so we just, 1 over x is you just flip it, right? So it's just u over u minus 1, okay? Now you can do this algebraic hack where you can add 1 and subtract 1 on top. That's basically doing nothing, right? But this helps out a lot because you can split this fraction up into 2 like this. And the first term is just 1, which we know how to integrate. That's just u. And the second term is just ln of absolute u minus 1, okay? And then we back substitute. What was u again? U is 1 over 1 minus x. So back substitute it there, and that's my final answer. So here, if you were able to see the substitution right away, great. Otherwise, let's go down the list of techniques. Integration by parts doesn't seem like it will be super nice because it is a product of two things, but then usually you want like one of the functions to become simpler when you differentiate it, but not the case for this. Okay. Not trigonal clearly. Can we do a trig sub? It might be possible, honestly. It is something squared minus something squared technically, because square root of x squared is x. But I probably don't want to attempt that. Make it messy. You could probably actually do a partial fraction composition as well here, because it's a rational function and there's linear factors, just a repeating linear factor. So it might not be as easy, but it's probably doable as well. So I just chose to do a substitution because I was able to guess that this might work. So I just went for it and then it worked out. Yeah, but you can, as I explained, this at least one other for sure method that would work, which is partial fraction decomposition. So you could attempt that as well if you like, as good practice. All right. Okay. Hopefully see you in the next video. Hopefully this was helpful.